So this video is going to help with answering any kind of normal distribution question that involves a z-score table. So we get a z-score table for normal distribution questions when our z-score isn't a perfect number. So when we don't get 1, 2, or 3, or -1, -2, or -3, we can't use our empirical rule that's given in the formula sheet. So instead, what the question will do is it will give you a z-score table, and you'll have to use that respective z-score table to find the probability under that curve. So the question will always give you the z-score table if you are required to use it. So you don't need to memorize any of the values. It will be given to you in the question. So we can have a look at this question. We have a random variable is normally distributed with a mean of 0 and a standard deviation of 1. And that this table here gives a probability that this random variable lies between 0 and z for different values of z. So we have been given our probability z-score table here, so we know that we have to use it for this question. We're told here that the probability values given in the table for different values of z are represented by the shaded area in the following diagram. For part A, it says, using the table, find the probability that a value from a random variable that is normally distributed with a mean of 0 and a standard deviation of 1 lies between 0.1 and 0.5. So we have our conditions here that we have a mean of 0 and a standard deviation of 1, so we can use this z-score table here. So what this question is saying is, because I'm trying to find the probability, that my z-score is sitting between 0.1 and 0.5. Now, I want to draw this in my normal distribution curve here, just so I can see what's going on. So I've got my 0.1 here, and I've got my 0.5 here. What I'm trying to find is this probability in here. So therefore, to find that probability in there, I'm going to find the probability that it's going to be less than 5, minusing the probability that it's going to be less than 0.1. So I get this little area in between here. So to write that down, that's going to be the probability that z is less than 0.5 minus the probability that z is less than 0.1. The z-score tells us that the probability that it's less than 0.5 is going to be 0.195. So I can write 0.1915 minus my probability that the z-score is less than 0.1, which is 0.0398. Okay, popping that one into your calculator and you get 0.1915 minus 0.0398 is equal to 0.1517. So therefore, the probability of that is going to be 15.17%. If we have a look at part B, we're now given a different scenario. So we have birth weights are normally distributed with a mean of 3,300 grams and a standard deviation of 570 grams. By first calculating the z-score, find out how many babies out of 1,000 born are expected to have a birth weight greater than 3,528 grams. So therefore, my desired value here is the probability that x is greater than 3,528. So it gives me a hint here that I want to find my correlating z-score. So my z-score formula is z is equal to x minus my mean over my standard deviation. Here my x value, like we said, was 3,528, and my mean as given to me here in the question is 3,300 all over my standard deviation of 570, which is given to us here. Okay, plugging that one into the calculator, you get your z is going to equal to 0.4. So what I can do is rewrite what I'm trying to look for in terms of my z-score is the probability that z is greater than or equal to 0.4. So if I refer to my bell curve up the top, so getting rid of my working out from the last question, I'm now working with my z-score being 0.4. So let's imagine this z-score here is 0.4, and I'm looking for it to be greater than 0.4. Now, we know that the way that the bell curve works is that we can only find the probability or the percentage of scores that are less than that desired z-score. So we're always working to the left-hand side. When we are working with to the right-hand side, we need to use the theory of symmetry here to help us. So to explain a little bit about what that is, if we have a look here, this table gives us the values that it's between 0 and 0.4. I can't use my empirical rule here because 0.4, it's less than 1. It's not a nice number that I have in my formula sheet. So I will be referring to my z-score table again. And it tells me that the probability that it sits between 0 and 0.4 is 0.1554. So this shaded region here gives us the probability of 0.1554. We also know that anything less than 0, so anything on the left-hand side or right-hand side of our mean, is going to be 50% of the data, so 0.5. So what we can say here is that this entire probability and this percentage here, that it's going to be greater than 0.4, is going to be 0.5 plus 0.1554, just by adding in my shaded diagram of my blue area and my red area there, which gives us 0.61554. Now, since we just found out the probability of this entire area here, the way that we can then find what we actually want to find, which is the probability that's greater than this, is if we go 1 minus, so 1 whole or 100% in probability minus our 0.61554. So what I've just done there, to pop it into some terminology, that the probability that z is greater than or equal to 0.4, by using symmetry as we could just see in the diagram, is going to equal to 1 minus the probability that the z-score is less than 0.4, which we said was 1 minus 0.6554, which is equal to 0.3446 or 34.46% of the babies that are born. So this question then wants us to wrap up by finding the expected value. So we know that 34.46% of babies born are going to have a weight greater than 3,528. So if 1,000 are born, we just have to find 1,000 times 34.46%, which is going to give us 344.6 babies. But rounding that up, we get 345 as our final answer. So we knew that we had to use a z-score table there just because we got a decimal place value as our z-score, so our 0.4, and they gave us the example at the start there. So hopefully that helps to work out how to use the z-score table in normal distribution questions. They're always going to give you the table, so it's a massive hint if you ever need to be using one.